Hello students, I am Ashish De. I am taking one of your subject, that is digital signal processing. In my earlier video, I have told about the classification of discrete time signal, and the first classification is energy signal and power signal. So I have defined whether a signal is energy signal or power signal, what will be the definition, and how to test whether the signal is energy signal or power signal. Now the second classification is periodic signal and aperiodic signal. Now a discrete time signal xn is said to be periodic if it satisfies this condition: x of capital N plus small n equal to xn, where capital N is called the fundamental period. So capital N is called fundamental period of this periodic signal. Okay, so if any signal xn satisfies this condition, then it can be called as periodic signal, otherwise it is called aperiodic signal. Okay, now what will be the formula to find out the fundamental period of any periodic signal? That is, capital N is equal to 2 pi into m by omega 0. Okay, so omega 0 is the fundamental frequency of the signal. As this is the recapitulation tutorial for you, you also know how to derive this formula to find out the fundamental period of this signal. Now any signal xn is called periodic signal if the fundamental frequency omega 0, so from here omega 0 has the value 2 pi by capital M by capital N. Okay, here m is any integer, and capital N is the fundamental period. Okay, so a signal is said to be periodic, any signal xn can be called periodic if the fundamental frequency omega 0 must be a rational multiple of 2 pi. So m by capital N has the value of any rational number. Okay, so if it the rational number multiplication of 2 pi, then the signal will be called periodic signal, otherwise the discrete time signal is aperiodic. Let us take an example. Suppose xn, in example 1, suppose xn is given by cos pi by 3 into n. We have to test whether this signal is periodic or aperiodic signal. So in this case omega 0 is equal to, what is the value of omega 0? That is equal, the signal is given by 2 pi by 3 into n. Okay, so the omega 0 has the value 2 pi by 3, right? Now this is the rational multiplication of 2 pi, because this is 2 pi into 1 by 3. So this signal is periodic signal. The signal is periodic. Now we have to find out the fundamental period capital N. Now what is the formula to find out capital N? The formula to find out capital N equal to 2 pi into m by omega 0. Now the value of omega 0 is 2 pi by 3, so this is 2 pi into m by 2 pi by 3. 2 pi cancel out, it will be equal to 3m. Since m is any integer, we can take any values of n. Okay, so for the fundamental period of this signal, we have to take the value of n, we have to take the least value of m when capital N is an integer. So the least value of n, m, will be equal to 1 when the capital N is equal to 3. So this is the fundamental period of this signal, of the given signal. Okay. So in your class test 1, this problem is given. So this is the procedure to solve the problem. So basically what we learn from these two successive videos, we learn what are the classification of discrete time signal and how to check whether any signal is energy signal or power signal or periodic signal or aperiodic signal. Again, there are two other classification that are symmetric or anti-symmetric signal. As we know, so symmetric or even signal. Any signal xn, if it satisfies this formula x of minus n equal to xn for all values of n, then it is called symmetric signal or even signal. Example is cos omega n. All of we know that cos omega n is an example of symmetric signal. Okay, if it does not satisfy this if n is for any signal xn, if x of minus n equal to minus of xn, then the signal is called antisymmetric signal or odd signal. So this is odd signal. This is the condition. So the example of odd signal is xn equal to sin omega n. All of we know that sin omega n is basically an odd signal which satisfies this condition. Okay, so any signal xn has the even part and odd part. So even part of xn is equal to xc of n and odd part of xn is xon. So we can easily find out the even part of any signal xn equal to half into xn plus x of minus n, and odd part of xn equal to xon, that is equal to half of xn minus x of minus n. Okay, so these are the formula to find out the even part and odd part of any signal xn. Okay, another classification, so this is the classification number 3. Another classification is causal and non-causal signal. Causal and non-causal. Spelling is CAUSAL. Causal and non-causal signal. Okay, a signal xn is said to be causal if its values is 0 for n less than 0. Otherwise the signal is non-causal. So xn will be equal to 0 if n less than 0. Otherwise the signal is non-causal. Okay, so example of causal signal is xn equal to a to the power n into un. This is the infinite duration causal signal. Again, xn equal to 1, 2, minus 3, minus 1 and 2. Arrow is here. So this is finite duration causal sequence or signal. The example of non-causal signal is xn equal to a to the power n into u of minus n plus 1. This is the example of non-causal signal. Okay, and in finite duration sequence, the example of non-causal signal is 1, 2, 3, minus 4. So if arrow is here, this is the example of non-causal signal, because this is the nth position. So this is 0th position of this signal. So this is minus 1, minus 2 position. So here xn has the value when n less than 0. That's why the signal is non-causal. But in this case, xn does not have any value when n less than 0. for negative values of n there is no value of xn, that's why this is causal. Okay, so you feel the difference between causal and non-causal signal. So what we basically learn from this two videos, we learn what are the classification of signal and how to realize the classification of those signals.